Today we're going to review how to do a cone beam CT's contrast injection. So first things first, you're going to acquire the cone beam. So that's going to be isocentering AP, isocentering lateral, and you're doing your region of interest. You're not centering the spine. So if you're doing a liver, you may need to move the patient a little to the side rather than pan the table, because the C-arm doesn't have a lot of room to spin around in the IR suite. So you might have to just move the patient over, or you're not going to be able to set your parameters. So isocentering AP, isocentering lateral, then you're going to select your program, and then you're going to follow the prompts on the screen to set your start and stop positions. So on a Siemens, you would move from one position to another by pressing down on the joystick and deflecting. On Philips, you are gonna, at least on this version, you are gonna hold the recall position until this flashing light here turns to solid green for your stop position, and then you're gonna hold the next one until you have a solid green button for your start position. So that is all good and well, except what if we're using contrast to see the vasculature? So to figure out how to do this, what you're gonna do is use this formula. So you're gonna use fill time plus spin time. That's gonna be your injection duration. And then your injection duration times flow rate is the volume that you're gonna set. So, okay, Annie, how do you figure this out? So let's write it again. Fill plus spin equals your duration. That's a little thick. And then your duration times flow rate equals the volume. All right, so what you will do is use the DSA run that is immediately prior to this spin, and where you're in the vessel that you're gonna spin. Usually we always do a DSA run before. So what you're gonna do is count how many frames until you reach max fill, or whatever the doctor wanted to see. Maybe he wanted to see more tumor blush. You're gonna count the frames on the DSA run. So for example, so if you have 6 frames, and the run was acquired at 3 frames per second, that would be 2 seconds. So you counted 1, 2, 3, 4, 5, 6. That's a great max fill image, or that's a great tumor blush. You acquired the spin at 3 frames per second. See, we're just dividing it. That's gonna be 2 seconds. So that would be your fill time. Your spin time is gonna be what's set on the machine. Commonly, that's gonna be 5, 8, even 10 seconds. So that's gonna be what, dependent on whatever program you selected. That's gonna be your spin time. So adding those together, let's say we used a 10-second spin. So 2 plus 10 equals 12. That'll be your duration. Now let's say we are doing a flow rate of 3. So you would do your duration times 3. And that would be 36 volume. So what do I set on the injector? We're gonna do, because your injector commonly has like then you would have like PSI. So your flow rate, that's gonna be dependent on what the doctor said. In this one, we said that they wanted 3, so we would do 3 and a volume of 36. PSI is gonna be whatever the package says. If you're in a microcatheter, obviously that's gonna be lower. If you have a selective catheter, obviously it'll be higher. Let's just say that was 700. And then you're also gonna have a delay that you need to set. So when we're doing a spin, we want contrast to be there before we spin. Okay, so we want the contrast to be there and stay there during the whole spin acquisition. So we need to set an X-ray delay. So this is gonna be an X-ray delay. And we're gonna use our fill time. That's gonna be your X-ray delay. So again, our fill time was 2. So we're gonna do a 2-second X-ray delay. And then we will be ready to arm and inject. So again, fill time equals X-ray delay. So hopefully that makes sense. We will do another example. So the doctor wants a cone beam CT with contrast for mapping. This one's in the book. It takes 4 frames for the vessel to reach max opacification. The run was acquired at 2 frames per second. So we're gonna divide that. That's gonna be our fill time of 2. I'll put up here, fill time plus spin equals duration times flow rate is volume. Just in case anybody wanted to look at that while we're doing it. Okay, so it took 4 frames to get what we needed to see. We acquired the run at 2 frames per second. That's gonna be a fill time of 2. So we got our fill time, check. The program selected for the cone beam is a 5-second spin. Spin time, check. So duration would be 2 plus 5, that's gonna be 7. Check. The physician would like the contrast to be delivered at 3 cc's per second. Okay, so we'll do the 7 duration times the flow rate of 3. How much volume is needed? So we're just gonna do 7 times 3, and that's gonna be 21 cc's of volume. So again, flow rate of 3, volume of 21, X-ray delay, and remember X-ray delay is the same thing as fill time, so that was 2, is 2. Should be perfect there. And then just make sure that you have the correct PSI for whatever catheter you're in, and you should have an excellent spin there. Key again is you want the contrast there and stay there. The whole spin. Otherwise, your reconstruction is gonna look pretty terrible. Anyway, hope this helps some people. Have a fabulous day.